on the JVM. And yeah, if you see too far, then you probably won't see the code example. So about myself, I work as a developer advocate for Cloud Foundry. Cloud Foundry is the platform as a service from VMware. That's my blog, Twitter, and so on. And I don't know if you know that, but if you heard about GIF-sockets, that piece of spam in your Twitter timeline was created by this guy. Blame me. And I also the co-author of the book RabbitMQ in Action. That's a messaging broker that also today is part of VMware. It's also an open source project, but was acquired by Spring Source. So regarding Vert.x, so I'm not an expert on Vert.x. I've been mostly reading about it and so on. I proposed this talk to Hannes like 6 months ago. I was not even at VMware, so the correlation with Vert.x being a VMware project is totally coincidental. And taking that into account, I'm not an expert, so maybe I'm able to answer your questions, maybe I'm not. Maybe I'm able to whet your appetite regarding Vert.x, maybe I'm not. So please hold your tomatoes where they are. So what is Vert.x? Vert.x is a VMware-sponsored open source project. It's JVM based, as I said already. It has more than a year in the works. And it's created by a guy called Tim Fox, which is the creator of HornetMQ. HornetMQ is a very fast messaging queue server. You can read more about that also. It doesn't belong to VMware. And yeah, knowing Tim Fox from what he created with HornetMQ, I was very keen to know more about Vert.x when he started tweeting about that, because I know Tim Fox knows a thing or two about scalability and whatnot. So it was nice to see what he was creating with Vert.x. So Vert.x can be branded as a framework to write polyglot, highly concurrent apps. So what does it mean? What is polyglot or what not? So from the get-go, Vert.x supports many languages. And the idea of Vert.x is basically, it's very similar to Node.js, but instead of being running on V8, it runs on the JVM. And instead of only supporting JavaScript, it supports many programming languages, plus some extras. So I don't know if you can read that, but that's the classic hello world for JavaScript. You load Vert.x, you create an HTTP server, you set a request handler with a function that will get the request, and if the path is index.html, if the path is the root, then you serve that file, else you serve whatever is on the path. And it's actually serving stuff from the web root folder. So that's the server in Java, which I think looks very similar to Node.js code. It's just JavaScript. Of course, it would look similar. And then if you want to run that, you just do Vert.x run server.js. Of course, you need to install Vert.x. Installing Vert.x is a matter of downloading the code from GitHub. Not the Git repository, the tarball. You uncompress that, and then you link Vert.x into your path, and that's it. By the way, it requires Java 7. It doesn't work with Java 6. And then what is instances 32? So if you have 32 cores, or you want to really scale your app, you just add this and it will scale automatically. Something that you cannot do with Node.js. Of course, you can use cluster on whatever library, but usually Node.js is single core, right? So if we want to do the same in Ruby, that's the code in Ruby. It runs Ruby by using JVM. Python via Jython, that's the code. And you have Groovy. If you want that, I won't name it. And there is plans to support, there is Python as well, and there is plans to support Closure and Scala. Basically, Vert.x has a core of course, written in Java. So if you expose that core into your platform, then you can have Vert.x in PHP via Kerberos, whoever want to do that. So that's for the polyglots. For the highly concurrent apps, I need to explain a bit what's the architecture behind Vert.x, or what are the concepts in Vert.x. But up to here, it's kind of, yeah, I can do that in Node.js, basically. What should I even care about that? Maybe not the instance. But. So, what are the core concepts on Vert.x? So in Vert.x, you have a vertical, and think about that as like a particle or something. So what your apps, let's say that the static file server I showed before, that's your vertical. So then you have Vert.x instances. Whenever you run Vert.x on the command line, that starts an instance. And each instance can run thousands of verticals according to what amount of RAM you have. And this is very similar to Erlang and the Erlang processes concept. It's very similar in how it works. Even it has the concept of message passing and whatnot. So then there is an event bus, which is more than just firing events. You can use that event bus for communicating across the cluster, or even communicating from the server to the browser. So basically, verticals run inside a Vert.x instance. A single Vert.x instance runs inside its own JVM instance. Bam. So so too many concepts for me. I'm trying to understand as well as you do, bro. So that's it. So you start one Vert.x server or instance on its own JVM, and then you specify how many of your verticals you want to run. So instead of having one server serving requests sequentially, kinda, like you would have in one Node.js app, this will fire 32 verticals and scale that and take care of having a thread pool for you and so on. So, and 2 slides from the end of this talk. Luckily there is beer, so you won't kill me. Anyway, so programming model is event-based. So it's very similar to Node.js. You have event handlers. Then per Vert.x instance, so that JVM instance, you have a set of threads. And the verticals are executed using the same thread. And you don't need to care about any of the data synchronization, logs, mutex, or whatever. You just have your vertical running there, and Vert.x will take care of not sharing data and so on. Yeah. As far as I was reading today and talking to Tim, you can actually isolate the class path, so you cannot share like static variables or anything in Java between verticals. So the data is really isolated. And the communication between the verticals, you do it via message passing. And if you don't want to do message passing, you also have share data structures, like a share set and share maps. But you cannot share mutable data, of course. It's all trying to be to have a high concurrency model that is as easy to understand as possible. So there is the core of Vert.x, which you can write TCP and SSL servers. That is all there. So you just do new TCP server or whatever the API call is. You can have HTTP servers, that's the one we saw already. You can have plain WebSocket servers or SockJS servers. I don't know if you have heard about SockJS, but I don't want to say it like that. But the guy said like it's a Socket.io well implemented. So you go fight against the SockJS guys. SockJS is actually kind of a specification on not for WebSocket but from web messaging. So if you use WebSockets or any of the fallbacks, that's what Sock.js will do. Then you can implement your server, your Sock.js server in whatever language you want, and the same in the client. Of course, there is already a Sock.js server for Node.js and Sock.js client in JavaScript for the browser, because that's what people use. But that doesn't mean you cannot implement a Sock.js server in Erlang. And yeah, so you can do the plain WebSocket, that is if it doesn't work in your browser, sorry, or you can use Sock.js with the fallbacks. And what I like about Sock.js is that it's created by the same guy that created RabbitMQ, which I assume know a bit or two about messaging. So that's also a plus I see in Sock.js, which happens to be an open source project at VMware. Sorry, I don't want to be a sales guy, but I'm doomed. Anyway, there is this distributed event bus that with that you have access to verticals in the same Vert.x instance or in the cluster. So when you run Vert.x, as I showed before, like Vert.x run, my app, whatever, you can have many options, of course. One option is cluster, then you can have the cluster port and so on. And Vert.x will take care of adding all the Vert.x instances into the cluster, and then you can use the event bus that you use to communicate among verticals, among Vert.x. They should find a new name for that. Anyway, and then you have shared maps and sets. I mentioned that before. And of course you have logging frameworks and like, there is stuff that I'm not showing here, maybe we can see code later, but as I see Vert.x is like a Node.js with batteries. What do I mean with batteries? There are already a request matcher, so the same functionality you get from Express.js regarding matching. I don't know how many of you have used Node. Maybe have used Node.js. Do you know Express.js? So in Express you define routes and then a function for that, like a callback. That functionality already is present here on Vert.x. And at the same time you can have modules and whatnot that you include into your apps. So, for example, by using the distributed event bus, you can share data from your Java vertical into your JavaScript one or whatever. You can also mix and match languages. You don't need to run only one language on your app. So, an example here on the event bus. It allows us to talk to each other, then it works cross-language and across the cluster. And the cool thing is it spans from server to client side. So this event bus, there is already a Vert.x, I don't remember the name, library that you include in the browser, and then you have direct link between the server to the client. So how does it work? It's very simple. You register handlers, you register them, and then you have addresses. So whenever you send an event, you send to an address, like a string saying my app dot my module dot whatever, or I mean, it doesn't really matter, but it has to be a string, and it's much better or recommended that you specify like path separated by dots. And then you can send messages. So you will register a handler for an address, and you send messages to the address. And messages are transient. So if something happens in between, boom, there is no more message. So you could build your own super cool messaging system on top of Vert.x, but you will need to implement all that part of message persistence and whatnot. So handle it with care, let's say. So that's the code for registering a handler. You get the event bus instance. You have a handler, just a JavaScript function, and you register for test.address. It's very similar to events, basically. Then, unregistered handler is the same, you remove from that. And then you can publish messages and send. What's the difference? In publish, you are doing the publish subscribe messaging pattern. So all the handlers will get the message if you do that code. In this case, only one handler will get the message, and they will be kind of round-robin across the handlers. That doesn't mean it will be exactly round-robin. And you can also do RPC. So in this case, you have an RPC server, so the handler can take a second argument, like replier, and you do something, and then you call that as an extra callback. And then on the client, you can do the same. And you send the message and add an extra function there, and this function will go to the RPC server. So I think that's very clear. So keep in mind this event bus will do all the scanning for you, the distribution across the cluster and so on. So that's the main difference. It's not just firing events, it's that those events can be across all the parts of your app and then across the cluster. And then yeah, you can have shared data because maybe you don't want to do everything via message passing. It could even be slow and whatnot. Like a shortcoming of Erlang is like you can do everything via message passing, but then maybe sometimes you really want to share data. You want to have data locality according to the CPU you're working on, and with Erlang you cannot predict that. And in the case of Vert.x, you could do that using this shared data structure, which are maps and sets. So in the share set example, it's actually pretty simple. Like it creates a network server with a function there, and this will do like a fan out to all the clients. So whenever you connect to this server, whatever you write there, it will go to all the clients. So here they have a connection set. Then every time somebody connects, it adds the connection to that set with the socket, the handler ID, and then sets a handler. Whenever there is data there, it will send it over to all the connections that are in this set. Do you follow that?
It's like registering handler of when set changes.
I mean, basically, that's the set, right? So every time there is a new connection, a new socket open, adds a reference in the set. And whenever there is data coming in that socket, it gets all the sockets registered here, and then it sends data to all of them. And yeah, that's it. So that's one way you could use that. Of course, you could use that set to just share data. It doesn't necessarily need to be to share a connection. I mean, whatever you imagine you could do, you can do it. And again, you maybe think only, or we maybe think only about web apps, but you could also have a TCP server, like, I don't know, for whatever protocol you want. Or that's all provided already by Vert.x. And the cool thing is, if you are doing a lot of Node.js, this can be easily, I mean, you can easily translate to that because it's the same programming model and even the same language. And of course, if you like one of the other languages, you could try doing it in that language. Speaking of Node.js, there is an effort from the community trying to have integration of Node.js modules into Vert.x. That's not complete as far as I know, but I think if they can expose the API, then that should be fairly doable. Yeah.
So what would happen if a client closes a handler during your loop to the for loop?
At this point, I don't know. But I assume every kind of these error conditions or whatever you have to handle.
Okay.
So benchmark, everybody loves benchmarks and wants to fight against them. So you can read, the best would be if you read the blog post. When the author, first the benchmarks are written by the guy that wrote Vert.x. So whoever writes a benchmark, always his platform is the best one, we all know that. Still, this is the URL, you can read all the details if you want. He tried with many languages for Vert.x versus Node.js. And he had Vert.x running with 6 instances compared to Node.js with 1 and Node.js with 6 processes using the cluster.js library. And you can see it's much faster. And this one was serving a simple HTML file that was returning 200 OK. It's as scientific as it goes. As the other guy writing a benchmark returning hello world in his laptop, and as the other guy doing I don't know what. The small difference I see here is like the first paragraph of the benchmark warns you about that. That is as scientific as it goes. And yeah, I mean, Tim, he wants to his focus right now is to having a usable project or product, not having nice benchmarks. So he wants to do that in the future. But right now, it's more trying to push the platform forward than just having useless data around. Because I mean, you can see in the framework wars on the internet, some guys put all the APC settings and whatnot on his beautiful framework, and then compares that against Groovy in one instance, I don't know. And yeah, it's a super cool benchmark, but it's totally useless. And it's pretty hard to get something that is as scientific, I mean, as possible using the network, having the real disk access and so on. Maybe the first time you read the file from the file system, the second time the file is cached. And there your static benchmark is completely crap because the second time it's not doing anything. Or when you try to benchmark MySQL and then the queries on the cache and then bye-bye benchmark and so on. So that to take into account all those little details is not so easy. Speaking of which, this is the static file benchmark. And you can read what this means below here, but TLDR is Node.js is much slower serving static files. And if you read the comment, there is a big discussion about why this is happening, and they told the guy that you are using Node.js wrong as usual, and then he changed the benchmark, it's still slower. And it seems that Node.js or the Node.js libraries in JavaScript or V8 or something around there doesn't use fully the operating system file cache, which the JVM does. Therefore, you see that huge difference. So maybe you can say this is totally crap, or at least I have a platform that it properly uses the operating system. You need to put stuff on the balance. If you have like one big drawback of Vert.x right now is like there are not that many modules. So you have Redis, you have MongoDB, and of course, if you have a library in the JVM that can be also used in Vert.x, but in Node.js you have tons of modules. So maybe you don't care about those numbers, but you do care that your application will be deployed in 1 month, and you don't want to write your new blah 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 client. So it's always drawbacks and decisions. So.
Is there any kind of restriction on what libraries you can use in Vert.x, or just any job you can?
as far as I understand, it's better if they are not blocking. So they prefer to have the non-blocking model as in Node.
You should use JVM.
But you can also have blocking libraries. In Vert.x, something I'm not talking in this talk, you can have blocking workers that will work. If for some reason you need that, like, I mean, you can specify that instance is a worker instance. So there is stuff the instance won't be able to do, and there is stuff the instance is able to do. So I don't think you want, and I don't think Vert.x will allow you to have like an HTTP server on a blocking instance because it won't scale at all. So that kind of stuff is restricted, but you could probably check more the documentation. I don't really know out of the top of my head the exact difference of what is allowed or not. But you can have blocking stuff, which you, as far as, I mean, you can have in Node.js, but then it's only one process. So there is no point on having a blocking library in Node. So yeah, that's for benchmarks. Now internals. So this is very short. It's like what Vert.x is built on, except besides the Vert.x code. So it uses the Netty framework, Groovy for Ruby, then Mozilla Rhino that he was telling me is not maintained or not. I don't know. I don't really know what's the stability of that. Then Python for Python and Hazelcast. I didn't know about that library, but when I was started reading about Vert.x, it seems to be a pretty advanced library for clustering and all this synchronization of data across JVM programs, which for me is one of the reasons why way back, like 3 years ago or so, I chose RabbitMQ in deployment we had in China. Because RabbitMQ was written in Erlang, I said, okay, another fanboy here. Right? No, it's not because of Erlang, because I don't know, I fell in love with Erlang. Erlang comes with a framework called OTP, and with OTP, you basically have fault tolerance, child node management, and clustering, everything for free. It's part of Erlang, the language. This means the guys writing RabbitMQ are not writing the new clustering code and their new message passing and the new whatever library, probably full of bugs, probably not taking into account edge cases and whatnot. And what I like from this part, and actually from what the team is doing, is like, okay, let's choose Netty, which is a established network library. Let's choose Hazelcast, which is also used for that, and so on. It's not like going to GitHub and what is this next project that can give me clustering? And okay, I will use that. And in this case, it's using mature libraries. That's why something that I appreciate from the project, that it's not trying to reinvent everything. And basically, for me, it's like, okay, you can have the same stuff as you get from Node, plus those extras of that, I would say, more complete event bus, or the clustering thing, or the talking from the server to the client directly, and so on, which you can do in Node, of course, but I believe you need to do a bit more stuff there. So go read there if you want to learn more. The website has a lot of documentation, examples, and everything. So if you have any questions, else I could show you some code on the command line and see some examples of apps that come already shipped there and see what can be done and so on. So,
do you know about any known applications written with Vert.x?
So I asked that today to Tim, and he said I'm not keeping count of that, but it's supposed to be announced on the Vert.x mailing list. I cannot give you a name. He told me, yeah, there are big companies using that, deploying in production and so on, but search the mailing list. So
okay.
I didn't have time today to. I got shocked actually. X-ray and whatnot this morning, so today is not a healthy day for me. So, any questions? Other questions? Do you want to see some sample code?
Yes.
Well, I hope you can read that. So here I have Vert.x, the folder. So this is what you get from the website, which this one. And this is what I show you today, what you can do in different languages and whatnot, documentation. You have like a main manual which is pretty complete actually. So that's something that also that you get a lot of documentation that you can read. You don't need to be reading the API or the Java docs for that. Then you have these tutorials. In this one you can write a real-time app, let's say on Vert.x. And also, there is the manual for each language. Like this is the one for JavaScript, and you get the whole API described. So I like that part also, that you get the documentation. Of course, I don't know how many Stack Overflow's answers are for Vert.x compared to Node. So anyway, then you have the examples inside here in the distro, and there are in many languages. I was checking the one in JavaScript. So, what was it? Yeah, there is the HTTP server here. Which is as simple as it gets. Get the server, create a request handler, and do something. Like return some response. Very basic. Then the one I told before, route match. This one. You can read that, or is so you have the route matcher. This is part of Vert.x also. What I say is it's not like you need to install an extra library, and then you get like for get, if these parameters are matching, do something else. Just send the index HTML file, and then you can create a server and listen to that. Let me see if this actually works. So that should be giving server there. Open. That's the server right now, and you can match by the URL. Very hello worldish, but it works. So another one, let me see. I think this one is maybe the one that shows the yeah. So basically, what they have here is they have the server, which is an HTTP server and has a request handler for two URLs. One is the slash, and the other one is this JavaScript library. And they set the servlet file. As you can see, also send file has a directory and the file name. So that's why I'm running all from this folder, from the JavaScript folder. From there I need to run the example. If I want to run them from inside the event bridge folder, I need to cd into that. And then it has a Social server, which if you send messages here, they will be handled. I am exactly not sure how they manage to send it back or stuff like that. Or if they just use that for communication with the event bus library. I need to read more into the code. And then you can see like they include the library somewhere here. Yeah, they include the Vert.x bus library on JavaScript. And then they have it here. If you have an instance of the event bus, just publish to the address and some JSON data. Then they subscribe. So the same code that was working on the server for register handlers is the same code you can run on the client. Yeah, and this is the address that we saw before. So by using Sock.js, they have the event bus server working there. So I don't know what you think about that. Then this one is a bit more advanced. Sorry, I don't show the running app. But because they have Vert.x come with a MongoDB persistor, they can actually bridge request from the HTTP to MongoDB directly. So when the address is this one, like this acts as a firewall, and the action is find, and on the collection albums, only for that MongoDB operation on that particular collection, they can already send MongoDB queries directly from the browser. And you don't need to do anything else. The MongoDB persistor will take care of connecting there, reading stuff from the database, getting back the response and so on. So if you don't have that, you expose the whole app to the client side, so the whole MongoDB to the client side. So that's why you have this kind of only expose that part, only for find albums and so on. So be careful. But I mean, I don't really know where I can show you the example of that. But this application was basically a store for music, so you can place orders and so on. I know it's deployed somewhere in .country, but I have no clue where. But yeah, if you find it later, or I don't know, I can send a tweet, or I don't know. It's just that amount of code, like 74 lines of JavaScript, gives you the whole application where you can place orders, have your cards, registered users, and so on. And all because it's just using this MongoDB persistor that will do all the bridging for you. So I know looking at Emacs is not so splendid, but you have to believe it, please. So don't know if you have any more questions or something.
Is there some kind of module repository or
Yeah.
kind of a new package management?
Yeah. So first, of course, you can create your own module, that's for sure. And then you have in the Vert.x GitHub account, you have the modules, which is the central repository. So if you don't have the module installed, it will be retrieved from there. So having the persistor running is just doing this code. And this will download it for you or have it inside your app. So in the app, here, those are the modules that were downloaded. So there is a web server, a system, and an authentication manager.
So you just try to deploy a module, and if it's not there, the first time it will go and fetch it. So you don't have a separate set next to installation.
No, it's just with the deploy thing. And of course, you can also write your own, and they advise that you write your apps as modules. So then you should deploy that. Then for the Java guys, you also have like a class path where you can provide to Vert.x, so it will load your libraries. It's better that you don't put your libraries on the global repo, because then it cannot guarantee that they will be isolated from the several instances.
From the viewpoint of the language, a module is a class, a function, object, what is it?
I think it's like a collection of functionality, but probably very similar to what we have in now. So for what I see here, I mean, I'm not that expert on that. You define the module name, whatever, configuration, and then the code that belongs to the module, like the application.js, and the stuff that the module is doing. Doesn't seem to be a specific, strict concept on that basis. And yeah, the same way you start your app directly from doing like Vert.x run app.js or something, you do Vert.x run module if you package your app as a
I really wonder how they do it across all the different languages, because like in JavaScript you can have just function, in Java you just cannot have just a function. But
yeah,
I
so
wonder what limitation it brings to being polyglot.
So basically you never call Java from JavaScript. You use the event bus to send messages. And you encode the messages in a format that all the languages can read. Of course, they also advise to do JSON, because there is a JSON parser for mostly every language. But if you have whatever other format, you could use that. And in the case of the JVM libraries, you should, if you want to use that across all the languages, then you need to write a module wrapper for the library. So then that can be exposed to all the clients, all the languages. Any question? So, thanks. And thanks to Google also for hosting the event.
No problem.